Equinox and Solstice. Equinoxes. In March and in September, neither end of the Earth's axis is tilted toward the Sun. Both hemispheres receive the same amount of solar energy because the Sun is directly above the equator. The time when the Sun is directly above the equator is called the equinox. And your length of daylight and night are equal. This is an easy way of remembering what equinoxes are. Equinox is where the Sun is above the equator, and day and night are equal. You can see in this picture where we have the spring equinox on March 21st in the northern hemisphere, and the fall equinox around September 22nd in the northern hemisphere. This picture, however, is misleading because it looks like the Earth is above and below the Sun, when truly we are only on either side of the Sun. You notice in both pictures that our axis is not pointing toward or away from the Sun, but they are both tilting at an angle toward the Sun. This puts our equator right directly at the Sun. Solstice. Solstices occur in June in the northern hemisphere. It's tilted toward the Sun, so it is warmer than the southern hemisphere. And in December, the opposite happens because the southern hemisphere is pointing toward the Sun. During a solstice, it is the time when the Sun is as far north or as far south of the equator as possible. Summer will have longer daylight hours, and winter will have shorter daylight hours. You can see in these two pictures where you have the axis pointing toward the Sun in the northern hemisphere and in the southern hemisphere. It is at these times that the northern hemisphere is having summer in June, and the summer in the southern hemisphere will occur during December. You can see here where the southern hemisphere is pointing away from the Sun in June, and the northern hemisphere is pointed away from the Sun in December, marking winter. You can see in this picture as well how we are tilting toward or away from the Sun in either hemisphere. So as the Earth moves around, starting here in March, we move counterclockwise and have from an equinox to a solstice, from a solstice back to an equinox back to a solstice. So in this picture, you can see here where we have the March equinox around March 21st. Now remember, the number of daylight hours is equal to the number of nighttime hours all over the world. And the vernal equinox in March marks the beginning of spring in the northern hemisphere, where the Sun is directly over the equator. As we move counterclockwise down to June 22nd, you can see where the North Pole is pointing toward the Sun, and the summer solstice is marking the beginning of summer in the northern hemisphere. There are more daylight hours in the northern hemisphere than in the southern hemisphere on June 22nd. As we move continuously around counterclockwise, we come to the September equinox around September 22nd, 23rd. And once again, equinoxes, neither the northern nor the southern hemisphere is tilted toward the Sun. Your autumnal equinox in September marks the beginning of fall in the northern hemisphere. As we continue to move counterclockwise around to December, and around December 22nd, we have the North Pole tilting away from the Sun, marking the winter solstice and the beginning of winter in the northern hemisphere, where there will be fewer daylight hours than in the northern hemisphere than in the southern hemisphere. Please put these notes into your folder so that way we can put them into your notebook tomorrow.